just use these. Of course, you have to design your shape. What shape do you want? Where do you want your holes? Hey everybody, it's Stove Talk with Matt, just breaking down yesterday's test. I wanted to show you the basic structure of the Firebox. It's very, very simple. Of course, I got too complicated in the last video, which was, per this recording, yesterday's video. If you just leave the front portion open, and you just take the sides and the back up 12, 14 more rows or so, and then you create holes on the side. And that's all you would need to do. And you put a brick box around this simple firebox. That's all you would need to do. I got a little too cute and too complicated in the last video. You don't need to do all that. This is all this firebox isn't done. You need to go up 12 to 14 more rows. But this is it. This is the basic design. My grate was at the top of level 3, and of course don't use this hardware cloth from Home Depot or Lowe's. It works great for tests. I mean, I've never burned through it, but it certainly wouldn't work for years in a real stove. It's great for my tests. You don't need to do this. It didn't do anything for me. I was trying to get more by putting in 2 grates. I was trying to get airflow. I wanted a lot of flame to come up the back side, and most of my flame, if you saw the last video, was in the center or towards the front, because all the air, 90% of the air, rushed up through that. Maybe if I wanted more to come out the back, I probably should have just done a very, very small air here. But either way, there's no reason to get this complicated. Again, that's my my New Year's resolution, but it's August. I would do the opposite. No reason to get cute like I always get. Just simply, where it's grate, put bricks. Where it's bricks, put grate. Simply reverse it. This should be the grate. Nice big grate right in the middle. This should be bricks. The back should be bricks. If it was my stove, I probably would do a small little slit in the back just to get some airflow up the back. I want again more flame running up the back. I don't want it just pouring all out the front. You need to find balance. Get all the bricks heating up evenly. But I don't want you to be confused from the last video. This front should stay open once you build the. You need this structure for the air vent and the ash clean out, and your bricks have to start going across to hold your wood. But once you build this, going up, it can stay completely open. Your red brick, of course, is going to be in front of this, going to be closed off with your door and your ash door. Your red brick should be. There's no reason to get it too close. They expand at different rates. You'll crack your stove. Just put your red brick a quarter. Well, I mean, don't get it because you lay bricks differently. All of a sudden, I found myself. I'd be like painting myself into a corner when I did mine. I should have just started it at 1/2 inch away, and kept a nice gap. And in the way you design the stove, if you think there's any, as the air flows over the top here and back, if you think it will want to rush down and go through that little 1/2 inch space and come out your door, you can just shove mineral wool in your 1/2 inch space between your red brick and your fire brick. You can, not regular insulation, mineral wool insulation, so you don't have any gases wanting to run around and maybe get out the cracks in your door if you're not using a real quality door. That's what I did in my stove. Leave the front open. So just to show you what the very simplest of fireboxes would look like, if the one from the last video was a bit confusing, you don't need that metal plate or anything. It's all that helps a bit, but this isn't to scale, of course. I just want to show you. You'd leave a 2 brick high opening by a full brick, maybe even 3, but much higher up, 10 to 12 rows higher than this, well above your door. And you leave the front completely open. All this is completely open, and you want to balance, of course. A lot of gases are going to want to come up over the back and down into your pipe. Some gases are going to do that, but maybe your logs that are burning more towards the front, of course, they're going to find their way out this way and that way down the side. So actually, since all the gases can escape over the top and down and around, and two would be good. But it's kind of an art. You want to make sure the front is attractive to the gases too. So I guess, I don't know, I would just do it by feel, depending on how high I wanted to go up. And you know, the firebox I showed yesterday was actually a little short. If it could go up 4 or 5 more rows, it should go up 4 or 5 more rows from the last video, because you don't want flame directly slamming into your red brick, which could happen if your firebox is a little short, like in yesterday's video. When that flame laps up high, it's going to smash against your red brick, and that's not good for red brick over the years. So try to go 3 or 4 more rows higher, and then you're just adding more mass, adding more bricks. It's all, anytime you can add more mass. Even in the back here, you know, somebody that wanted to extend their brick out 12 to 14 inches, you could, you know, move your pipe back. You could stack cinder block up the back, all the way up 4 feet, as long as the cinder block with big holes, so it allows all the gases. The more mass, the better. Here's how I do my grate for my tests. I just lay at the 4th level, including the base. I just lay hardware cloth. I never remember that name. It's not intuitive. It's not cloth. It's just, I never can remember. It doesn't make any sense. I just lay this grate across where I make my holes, and you certainly don't want to use that for a permanent stove. It'll only last for, I don't know, it won't last long. It might last a year and then it'll burn through. But I've never had a problem with the tests. But you don't want this for your permanent stove. And then just put a piece of another firebrick right on top, and it doesn't really. It doesn't really make the firebrick crooked or anything. It hasn't really thrown off my tests for the level. So just use these. Of course, you have to design your shape. What shape do you want? Where do you want your holes? And in a permanent stove, maybe I can find an old video, or I'll point you to an old video in the description, where with a certain type of 4.5 inch blade they're called angle grinders, you can make slits in the firebrick, and you can probably find a way just to place in small pieces of rebar, or I bought these stainless steel coat hangers you could use. And if anybody's saying, well, that'll burn through in a few years, they will. But if you could find a way, if you can make that groove, as you go up. Hold on a second. I'm thinking, although I've never tested, you're gonna make your grooves, you know, for your pieces of coat hanger here. But if you could make your groove going up here too, so what if it burns out in a few years? You could lay another one in. You know, you could keep replacing it as long as you could reach into the stove far enough. Again, like I said in the last segment or 2 segments ago, don't get cute. The air, this should be brick, this should be brick, where the brick is should be air. Just do it in the middle. In terms of mortar, I don't recommend this, but when you use a stove design, the stove design of just 2 bricks across, 2 fire bricks across, each being 9 inches, then you can do hundreds and hundreds of different designs without any expertise, without angle irons, holding brick. It all supports itself. So I mean, I don't recommend this for the base where you throw your wood, but this will just stay on its own. Especially when you build up the sides, that holds everything in place as you build up the sides. But you know, you still want to use a little refractory mortar. Dunk your fire brick in a bucket of water for 15 to 30 seconds, and then butter your refractory very, very thin, and push your joints together 1/8 inch to 1/16 of an inch, or almost like there is no joint. You don't need much. A 40-some pound bag of refractory mortar goes a long way with fire brick, because you're not using very much per brick. So you don't really, you need a little bit of strength, but you really don't even need the strength. for this type of design. It's all going to be supported anyway. And then finally you get to the base. I think in the last video I said it was 3.5 down. It's 4 down, as you can see, and it's just 2 across. 4 down, 2 across. And of course, I mean, for anybody new, of course, on your next row, always make sure you stagger and put your next brick across the seam. Of course, sometimes you need a half brick to do that. In certain places you can get away with 2 bricks on top of each other. It's not the end of the world, but try to stagger whenever you can. These designs usually work out very well when you stagger. Some designs you get, you know, you're at the end you do need half bricks. Some designs need a lot more halves than others. Smoke is becoming a big issue for many people around the world. Emission standards, pesky little EU inspectors, San Francisco inspectors. Did I see smoke coming out your chimney? You know, we got to put up with this. We all go for no smoke, but every once in a while there's going to be some smoke. So I've told you before in other videos, guys, I won't even put forth a stove that puts out a lot of smoke. Many of the stoves I've put out go to no smoke for most of the time. So that is an issue. And let's just have a brief conversation about, you saw from the last video, this does go pretty smoke free. And if you think that's a skinny firebox, I love the skinny firebox, but I love it for no smoke. You see how the soot was burned off the sides? You see how the soot, it cleans up when it goes high temperatures. And a thin firebox, I love these thin fireboxes of just 1 brick. It creates, very high and thin, creates a tremendous amount of heat reflecting back and forth. With the right amount of air, it burns up smoke. And if it's a very high firebox and thin, it goes no smoke very, very quickly. Again, you get some smoke to start for 5 minutes until everything heats up. You might get some smoke at the end when it smolders. But that is an advantage of this. And if you remember also, the way even you stack your wood, if you're worried about smoking, even if it's just being polite and you don't want to smoke your neighbors out or whatever, the way you stack the wood is important. To make sure it's stacked, you know, spend that extra time stacking so it's like a grid, so air can flow through all the wood. If you have big pieces of wood and logs with flat sides laying against the walls, that creates a tremendous amount of smoke. Again, my stove here, you're just looking at the base. This stove is a grate stove. You know, the wood is laying on a grate where air is coming up from underneath. These principles are even more important if you have a hearth stove. You could build the stove from the last video just like this, throwing the wood right on the fire brick. It's going to smoke a lot more. A hearth stove does. So when the wood lays against the sides, no air can get in there. It creates a lot of smoke, and you need super high temperatures to burn that up. So the way you make the fire, you're making it like a grid. I've even thought if I was in a location where I absolutely needed no smoke, you know, like some European country or something like that, and where I'm going to try to get away with this without the inspectors knowing, whatever it may be, you could put, if you had little nails even, now you have to get a nail that like titanium or that doesn't melt, or the highest quality of stainless steel. If you even had little nails, just 1/4 inch or 1/2 inch poking out of all the seams, you put like a nail right into your joint, and you had, you know, it wouldn't be good if you reached in to cut yourself, but it would keep, if it kept the wood off the sides and just allow 1/4 inch of air to flow between the walls and the wood, that would it sounds stupid, but that would eat up a lot of smoke. It's the dead wood laying against the wall that creates a lot of smoke, mostly in a hearth stove like this. You're just throwing it on that versus a grate where the air can come up from underneath. So this might be a stupid conversation. If you're just listening to this and you're in Kentucky somewhere on 4 acres, it's a stupid conversation. You don't know what these, you know, people in Europe and the standards there, or even, I mean, they're probably, most countries, they're not even allowed to, wouldn't even be allowed to build a stove like this. Of course, you can spend, you know, you got some rich person could spend $25,000 on Tulakivi soapstone masonry heaters, and all that would be approved, of course. and the super rich could build their $35,000, $40,000 masonry heater. It would all be approved. But if we're trying to stay warm, then that is not approved. You get some asshole inspector knocking at the door saying, did I see smoke? It's not Pennsylvania is still pretty free here where I am. Pennsylvania. It's European countries are, well, this really, you didn't sign up for a political discussion, did you? Bye-bye. You polluter. What are you going to do with that, Matt? Get off your ass and put it in the trash. No, this stuff this ash is incredibly good for, if I just left it there or put it in the forest, it is incredibly nutrient rich. So I'm not, just wanted to address this. You got some Karen somewhere watching this. I'm not polluting. This will go and be spread out in there, and it is really good. Now coal remnants are not. Coal ash, no. Yeah, that should be disposed of. Wood ash is great for the environment.